solved the problem based on eigenvalue and eigenvector, and we calculated the characteristic equation, and the second step is eigenvalue. The third step we are going to calculate the eigenvector. So the eigenvector, it is denoted by capital X. This matrix will be a column matrix. So what is a column matrix? It can add one column and it can have many rows. For our given matrix, it is 3 cross 3 matrix. So we will add 1 cross 3, 3 cross 1 column matrix for X. So the eigenvector X of A corresponding to the eigenvalue lambda is given by the equation A minus lambda I into X equal to 0. So the general form for the other given matrices, 2 minus lambda 1 minus 1, 1, 1 minus lambda minus 2, minus 1, minus 2, 1 minus lambda. So what I have done here, the given matrix, in the diagonal we are just subtracted lambda. So whatever the given matrix is given, in the diagonal just add minus lambda. So this is our A minus lambda I. And X, what is our X? It is a column matrix. So here I will get 3 rows and 1 column. So x1, x2, x3 equal to 0. So this is the standard form for the eigenvector. So first case, let us take one by one eigenvalue. So how many eigenvalue we got? We got 3 eigenvalue. So I am taking the first eigenvalue as minus 1. So you just substitute minus 1 in place of lambda. So 2 minus of minus 1, I will get 3. What about here? 1 minus of minus 1, 2. 1 minus of minus 1 is 2. So substitute the eigenvalue we got minus 1. Substitute here, you will get one matrix. And x1, x2, x3 equal to 0, 0, 0. So from here I can get 3 equations. So how to write the equation? You multiply each element, corresponding element. 3 into x1 is 3x1. 1 into x2 is plus x2. Minus 1 into x3 is minus x3 equal to 0. So take the second row. 1 into x1, 2x2 minus 2x3 equal to 0. Take the third row, minus x1 minus 2x2 plus 2x3 equal to 0. So from this matrix, I have got the 3 equations. So in order to find the eigenvector, I have to find what's the value of x1, x2, x3. I can solve this equation 3, we have 3 equations. We can solve these 3 equations and get the value of x1, x2, x3. We have 3 equations. You can take any 2 equations and solving these 2 equations you get the values of x1, x2, x3. So what I have done, I have taken the first and second equation. So the first and second equation, what are the unknown we have? We have x1, x2, x3. So what you do, to take from the constant from the middle. What is the constant here? Coefficient 1. 1 minus 1. 3, 1. So I have to take the constant from the middle term. 1 minus 1, 3, 1. The next equation 2 minus 2, 1, 2. So take the coefficient from the second term. So second term, third term, first term, second term. So for x1, to take these two numbers. x1, 1 into 2 minus 2 is minus 2 plus 2. For x2, these two, minus 1 into 1 is minus 1, minus 2 into 3 is minus 6, here plus 6. For x3, these two, 6 minus 1. So calculate this, x1 by 0, x2 by 5, x3 by 5. So you can cancel, simplify it, 0, 5 table 1, 5 table 1. So I am getting the values as 0, 1, 1. So this is the value for x1, x2, x3. So the first eigenvector corresponding to the lambda value minus 1 is x1, denoted as x1. and the eigenvector is 0, 1, 1. So we have the next eigenvector, that is lambda equal to 1. We have 3 eigenvectors. So for minus 1, we start the procedure. For lambda equal to 1, if you do the same procedure, you can get the eigenvector corresponding to 1 as 2 minus 1, 1. It is denoted by x2. Our next eigenvalue is lambda equal to 4. For lambda equal to 4, when we find the value of eigenvector, it is denoted by x3 and it is 1, 1 minus 1. So we got the 3 eigenvector. So when a matrix is given, we first see the order of the matrix, and to find the eigenvalue, eigenvector, the first step is to find the characteristic equation. The second step is to find the eigenvalue. You can find it either by synthetic division or by factorization. And the third step, for each eigenvalue, you can find the corresponding eigenvectors.